This is the video key for chapters 12 through 14. You'll notice, again, these are the formulas that you'll have given to you for the exam. So question 1, the colored beads in a box follows this probability distribution. Notice you have the colors across the top, you have the probabilities, but the problem is we're missing the probability for orange. So I want to know, what is the probability of getting an orange bead? Well, remember, all chances have to add up to 100%. So if I do 100% minus 16% minus 24% minus 31%, I should be able to figure out my missing percentage, which should be 29%. Next, number 2, an engineer at General Motors collects data on the weights in thousands of pounds and the fuel economy of some vehicles and does the scatter plot. And we drew a regression line for miles per gallon on weight. So that means we want to use weight to predict our miles per gallon. So first, let's find the equation of the regression line. So I'm going to start up here. Slope is equal to r times the standard deviation of y over standard deviation of x. So let's see, first you need to figure out which one's x and which one's y. It says we want to do miles per gallon on weight. Okay, that means we want to use weight to predict our miles per gallon. So weight is our x and miles per gallon is our y. Okay, so standard deviation for y is 6.46. Standard deviation for x is 0.69, which gives me, oh, oops, I forgot my correlation there. Let's see, r is negative 0.91 times the standard deviation of y, which is 6.46, divided by the standard deviation of x, which is 0.69. This should give me negative 8.52. So that's my slope. Now let's find the intercept. The intercept should be equal to the average of y minus the slope times the average of x. So the average of y is 24.64 minus our slope of negative 8.52. Notice that is minus a negative, and times the average of x of 2.89. Putting that into my calculator, I should get something close to 49.26. Okay, so we found the slope, we found the intercept. Now the equation of your line, y is always equal to your slope times x plus the intercept. So in our case, y is going to be equal to our slope of negative 8.52 times x plus the intercept of 49.26. Now you can leave it like this, or I prefer to put it back into terms of what I'm working with. So I would actually say here, y is my miles per gallon is equal to negative 8.52 times x, which is weight, plus 49.26. To me, that's just a little bit easier to work with and helps me remember which ones are my x's and y's. So first, what is the slope and interpret it? Well, our slope, we found out, is negative 8.52. To interpret it, it means if x goes up 1, y goes down 8.52. Okay, so that's my simple answer. I like to write the simple answer first and then try and interpret it in context or see which answer matches on the test. So let's see, x is weight. So if we go up 1, except for, remember, we're dealing with thousands of pounds. Our units were thousands of pounds. So if we go up 1,000 pounds, we predict miles per gallon to go down 8.52. Now remember, if you just have an observational study, which this looks like an observational study, they just took the cars that already existed, you can never say anything as cause and effect. Okay. So sometimes when we write our interpretations, we say if weight goes up 1,000 pounds, miles per gallon will go down. And we might say it kind of like is cause and effect, but if you're careful, this should not be cause and effect anytime you have an observational study. Next, what is the intercept? It is 49.26, and that basically means if x equals 0, y equals 49.26. So if weight equals 0,000 pounds, we predict miles per gallon is 49.26. Now, obviously, this one is a silly one. Remember, it's okay if you get a silly intercept interpretation. Sometimes they make sense, but the problem is we fit it for what makes our line fit the data, not necessarily for something that's logical. You can't have a car that's 0 pounds. Doesn't mean our interpretation is wrong. That's according to the graph. When weight is 0, miles per gallon is going to be 49. Our axes are kind of off here, so the weight only went down to 2. Predict the miles per gallon for a car weighing 3,200 pounds. Well, if you have 3,200 pounds and our units are thousands of pounds, x is going to be equal to 3.2. All we have to do is plug that into our equation. I like predicting much better with the actual line than with the regression method. So all I have to do is plug it in. So miles per gallon is going to be negative 8.52 times my weight of 3.2 plus 49.26, which gives me 21.996 miles per gallon. And predict the miles per gallon for a car weighing 6,500 pounds. Well, that would be x equals 6.5, and we just plug it in. So miles per gallon equals negative 8.52 times 6.5 plus 49.26, which gives me negative 6.12 miles per gallon, which should probably make you say, wait, what? You can't have negative miles per gallon. So let's go back up and look and see what might have happened. Notice our graph our data only goes from like 2, maybe like 1.9 up to maybe like 4.5. So when you look for 6.5, you're going to be way down here. That's why we got a weird answer. We were far away from the rest of our data. Remember, that's what we're going to call extrapolation. So that's why I put in part F here. Is it appropriate to use the regression line to predict the miles per gallon for that car weighing 6,500 pounds? And the answer would be no, it's extrapolation. Okay, it's not close to our other x values. So you can only use the regression line close to your other x values, so somewhere close to like 2 to 4.5. That's the only time when we can guarantee it's going to give you accurate results. Now we'll switch gears back to our chance and probability. So Sean has this set of blocks that you can see here. If he draws one block, what is the chance that it is not a 4? Okay, so anytime you have not, you probably want to use the complement rule. So the chance that it is 4, well, let's see, there are 3 out of 22. So then the probability of not a 4 is going to be 1 minus that. So we get 19 out of 22. Now, on the exam, it's kind of hard just to make sure everyone matches up. Sometimes these will be in decimals. So if you want a decimal, you can put it into your calculator as you do 19 divided by 22. So 19 divided by 22 gives me 0.8636. Or she might tell you to put it in as a percentage. So you move your decimal 2 places over or times by 100, so you get 86.36%. So on the exam, it might ask you for like a fraction, it might ask for a decimal, it might ask for a percent. She quite often says, put in the percent, don't type in the actual percent sign because that confuses Canvas. So you just type in 86.36. If he draws one block, what is the chance that it's going to be a 6? Well, if you look at, there are 3 6s So the probability of 6, there are 3 out of 22. Again, you can put this into your calculator. 3 divided by 22 is 0.136. Or if you times that by 100%, you get 13.6%. Now, if he draws 2 blocks and the first block is a 2, what is the chance that his second block is a 2? This is what we call our conditional probability. It's a very important note. It did not say and. It did not say what's the probability of getting the first one as a 2 and the second one a 2. It said, let's see, you're looking for the probability of getting a 2 if the first was a 2. So you're saying, I already know that the first one was a 2. Now, given that, what's the probability of getting another 2? So it's not an and problem, it's just a conditional probability. So if you already had 1, 2 out, then you only have 2 left. And instead of 22 blocks, you only have 21. So you get 2 out of 21. Or 0.0952. Next, if he draws 2 blocks, find the probability that he gets a 6 and a 6. So this one is our and probability. When you want the probability for an and, you have to multiply. So we want a 6 and 6. Well, to get your first 6, there are 3 6s out of a total of 22. Now we're going to multiply. Anytime you want an and, you multiply. But I used up one of my 6s, so there's only 2 6s left and 21 total. Sometimes, so again, I don't write these exams, okay? It was written by someone in the department. So she will often actually just leave the final answer like this instead of worrying about if you have fractions or decimals or percentages. So just keep in mind, she might actually just write it like that. But I put it in my calculator and I got 0.0129. Let's see next. If he draws 1 block, so now we're back down to 1, what's the chance that it is a 6 or an 8 or a 1? So we're looking for or probabilities. So and you multiply or you add. So we're looking for the probability of a 1 or a 6 or an 8. Well, the probability of 1, there are 2 out of 22. Plus for the or. Now, if you want a 6, now remember, we're only drawing 1, so we don't have to worry about the replacement or without replacement and changing our probabilities. Let's see, for 6, there were 3 out of 22. And for an 8, there are 3 out of 22. Which should give me 8 out of 22, or 0.3636. If he draws 2 blocks, what's the chance that they are both 2s or both 5s? So this one we're going to do and or. So we're looking for basically the probability of a 2 and a 2. We're going to do that first. Or a 5 and a 5. So to get a 2 and a 2, there are 3 2s out of 22. But if you use 1, then you only have 2 left out of 21. Plus for the or. Now 5 and 5, you start with only 2 5s, so 2 out of 22. And then the next time you'd only have 1 left out of 21. So 0.0173. Okay, so now for the next one, for each possible pair of events, I want you to label them as either mutually exclusive, independent, or neither. Now remember, mutually exclusive and independent mean completely different things. You're not even trying to measure the same thing, so it's not like it's one or the other. And in fact, most situations are neither. These are just very special cases. So before we try and look at them, let's remind ourselves of the definitions. So mutually exclusive means they can't happen together or at the same time. It doesn't always have to be strictly time. To me, that definition just makes more sense. Like they can't happen together or at the same time. Okay. Independent means they don't affect each other. Okay. Or knowing one happened. Sorry, trying to type at an angle. doesn't change the chance for the second one. So those are our definitions. Let's come back and figure out which one's which. Okay, so first block is a 2, and the other event, first block, is a 6. Well, first of all, can those happen at the same time? If you draw only one block, can it be in a 2 and a 6 at the same time? Well, assuming that we only have those blocks, I'm going to say, no, you can't happen at the same time. Or it can't happen on the same block. So it is mutually exclusive. Okay, next, if we draw with replacement, we're looking at the 2 events. The first block is a 2 and second block is a 6. Well, let's see, those could happen at the same time. You can get the first block 2 and second block 6, so it's not mutually exclusive. So let's check independent or not. Okay, let's see, if you use with replacement and you put them back, the first block should not affect the second block. So the first shouldn't affect second, so it is not independent. And we'd already checked in the beginning, it is not mutually exclusive either, because they can both happen. Let's try your next one. Without replacement, first block is a 2, second block is a 6. So without replacement means we don't put it back. Let's see, first check for mutually exclusive. First block is a 2, second block is a 6. Those could both happen. So it's not mutually exclusive. But if we don't put the 2 back, that is going to change the chances for my next block because there will be less blocks to choose from. So the second time, there are less blocks to choose from. So they are affecting each other. So they would be dependent. Or in other words, not independent. And then also they are not mutually exclusive because they can happen together. So in this case, it was neither.